In this lesson, we're going to learn how to calculate the percent by mass of an element in a compound, and then how we can use that information in problems. Remember, when we're looking at percentages, regardless of what the percentage is, the percent equals the part over a whole times 100. This basic definition of a percentage applies to any situation. For example, when you're calculating a grade, if you had 45 points earned out of 50 points possible, we would say the 45 points earned is the part, 50 points possible is the whole, multiply that by 100, and we get 90%. We also need to look at how we interpret percentages. For example, if we say 20% of the marbles are blue, that means 20 marbles out of 100 are blue, or 1/5. And sometimes we'll see fractions written in decimal form. 0.20 means the same thing as 1/5. Let's look at an example of how many blue marbles if we had 50 marbles total. Remember that percent is part over a whole times 100. We know that the percentage is 20% because we were given that information. We don't know the part because we're looking at how many blue marbles out of the 50 total. So that's our part. We put in X for that. 50 goes in the denominator because that's our whole. Multiply that by 100. If we divide both sides by 100, we get 0.20 equals X over 50. Then we can multiply both sides by 50 and get X equal to 10. If we have 50 marbles total and 20% of them are blue, then we'd have 10 blue marbles. We can do something similar when we look at the next example where we talk about 80 marbles. We know 20% equals X over 80 times 100 because 80 is the whole and we're looking for the part. X equals 16. What is 35% of 85? We know the percent and we know the whole. What we're trying to find is the part. 35% equals X over 85 times 100. 0.35 equals X over 85. And then we multiply both sides by 85 and we get 29.75 equals X. And we're going to round that to 30 because we have only two significant figures in our numbers. Now we need to look at how we apply this to chemical compounds. What is the mass percent of chromium, which has the symbol Cr, in aluminum dichromate? The first thing we're going to do is write down our formula for percent, part over a whole times 100. In this case, we're looking for the percentage. We have to get the values for part and whole. Even though they're not explicitly given in the problem, we can actually find out what those values are. What I'm going to do is take 6, because there are 6 chromiums in this compound, because we have 2 chromiums in each dichromate, and there are 3 dichromate groups, for a total of 6 chromium atoms in 1 unit of aluminum dichromate. I'm going to multiply that by the molar mass of chromium, which is 52.00 grams per mole. And then in the denominator for the whole, I'm going to get the molar mass of aluminum dichromate, and that is 702 grams per mole. And I'm going to multiply that by 100. And when I do, I get 312 over 702 times 100, which ends up being 44.4%. If I look at aluminum dichromate, 44.4% of the mass of whatever size sample of aluminum dichromate I have is going to be from the presence of those chromium atoms. What is the mass percent of chlorine in MgCl2? And the molar masses for both of those are given. Again, we're going to start with our percent equation. Percent equals part over a whole times 100. Our chlorine is the part, and there are 2 chlorines in each unit of MgCl2, so I need to take 2 times 35.45 grams per mole, which is the molar mass of chlorine. And in the denominator, I'm going to put the molar mass of the compound, which is 95.21 grams per mole, then multiply by 100. Percent will equal 70.90 divided by 95.21 times 100, which results in 74.47% chlorine in MgCl2.